charge by using the disk's result. So here we have our disk with radius r and our point charge, which is z away from the center of the disk. And here is our formula for calculating the E field at that point charge. And so now we're using this to try to estimate or look at what an infinite plane how it would affect such a point charge. So if we think about it, an infinite plane would keep extending larger and larger and larger. And so essentially r becomes infinite, or in respect to z, r gets very, very big. So when we look at our equation here, and we look at this part right here, we can pretty much write this as 1 over the square root of r squared, neglecting z, seeing as it becomes so much smaller in comparison to r. And as you can see, that just equals 1 over r, and as r gets really big, that is just equal to 0. So looking back up here, we realize that that is just 2 pi sigma k times 1 minus 0. Get rid of this because that's just timesing this by 1. So we're left with this being the equation for the E field outside of an infinite plane. And so we can rewrite that by transforming k into its 1 over 4 pi times epsilon. So by replacing that, we get 2 pi sigma over 4 pi epsilon, canceling out the pi, getting rid of a 2, bringing a 2 right here, and our final answer for an E field outside of an infinite plane is sigma over 2 epsilon. And we can see that the distance z is redundant. Perfect.